So students, I'm going to do this video. There's two parts of the video. I started this problem. I realized I made a mistake. So I just wanted to re-record this part here. So we're going to do binary search with strings. Okay, so we're looking for in. Okay, so one thing I noticed also is, first of all, I'm using a different version of, I noticed that the worksheet is using a different version of binary search where I can give you the upper, right, I'm telling you the number of elements and also the initial index. So the one I have online just tells you the number of elements. It tells us what allows us to look for a subset, but that subset always starts from 0. That's not a big deal. Okay, so I'll rewrite the worksheet so it doesn't have that. Okay, so let's just solve this problem. We're looking for in. Okay, and so remember we're gonna iterate through the array, and we're gonna find the index of in if it exists, which it does. We can see. So for iteration 1, the low always starts at 0 for our problems, and the high is always the number of elements in the array minus 1. So the number of elements in the array is 28, so it's 27. So the mid is 0 plus 27. So our initial mid is 13. Okay, so now we have to ask ourselves is, let's look at position 13 in the array. So it's green, GTA is 9, so it's no. Let me just double check that. E is 3, green is 6, JTA is 9. Yeah, okay, so now we're going to ask ourselves, is no is definitely not equal to in, and it turns out it's actually greater than in. Okay, that means since the array is sorted, not only can we eliminate position 13, but we can eliminate all the positions greater than 13 because the array is sorted. We know that if in is in the array, it's got to be in position 0 through 12. Okay, so what we're going to do, so for the next iteration, the low stays the same. So we go to the left, we reset high, and the high is always going to be mid minus 1. So it's going to be 13 minus 1, which is 12. And now let's calculate mid again, and it's low plus high over 2, which is 6. So now we're going to look at position 6, which happens to be green. Okay, so now green is actually less than in, right? So position 6 is, what's at position 6 is less than in. Everything, all the indices less than 6 have to be no store of value that's less than in because the array is sorted. So we can eliminate what's at position 6, and everything in to the left is 6. So now, we're going to look to the right. So in this case, we reset the low to mid plus 1, which is 7. So now low becomes 7. And your high, so either it's high changes or low changes, but never both. Okay, so the low is 7, the high is 12, and now we have to find the midpoint. 7 plus 12 over 2, so 19 over 2 is, yeah, that's my cat is looking for attention, is 9. Okay, so yes, 19 over 2 is 9, yeah, because we're using Java arithmetic. Okay, so now we look at position 9, which is JTA. Right, so that's correct, JTA. Okay, so now we ask ourselves, JTA is greater than in. That's what, remember, we're looking for in. So that means everything to the right of JTA is greater than in. So we can eliminate everything to the right of JTE. And so then the next iteration will look to the left. So the low stays the same. The low is 7, but your high is now is mid minus 1, which is 8. And now your mid is 7 plus 8 over 2. So your mid is 7. Right, 15 divided by 2 is 7 in Java. And then it turns out, both these Boolean expressions will fail. So your mid is 7. And so you ask yourself, so the Boolean expression on line 13 fails. Numbers of 7 is not less than in. And then 13, numbers of 7 is not greater than in. So you return 7. So it took 4 calls to binary search. So we have an array of length 18, log base 2 of 28 is a little more than 4. So it took about 4 calls. It took exactly 4 calls to binary search to find the index of in. So we actually return 7. Okay, so now let's go down to the next one. Okay, so this, here we're looking for NS, which is not in the array. Okay, so initially, it's the same problem, same array. So initially, low, so for 1, low is 0, and your high is going to be the last index, 28 minus 1, which is 27. And again, your mid is 13, 27 divided by 2. Okay, so now, and we already did this. So the first time, so your mid is, what was it? No. Okay, so E is 3, green is 6, JTA is 9. Yeah, so I think, let's just double check that because I'm making so many mistakes today. Green is 6, JTA is 9. Yeah, so, okay, so no is actually less than NS, right? NO is less than NS. The N's are the same, but O is less than S. Okay, so we know that everything to the, if no is less than NS and the array is sorted, everything to the left of no can't be in it. So we've just eliminated half the, so we don't have to search the left half of the array. We just cut out half the array with one iteration. But of course, the sorting could take a long time. Okay, so now we're going to look to the right. So when you look to the right, you reset low to mid plus 1. So low is equal to 13 plus 1, which is 14. High stays the same, 27. Okay, now you recalculate mid, and it's 14 plus 27, 41 over 2, which is 20. So your mid is 20. So next time around, yeah, so and then we go to 20. Okay, so the no is 13, so the 1 is 16. I think it's ST is 20. Let's double check it. So the green is 6, the JTA is 9, the many is 12, on is 15, pink is 18, ST is 20. So for 3, and so ST is greater, so we're searching for NS. ST is greater than NS, so everything to the right of ST is greater than NS. So we're going to look to the left of ST, so we reset high. So low stays 14, high is, so high gets set to mid minus 1, so your high is 19. And now we're going to find the average of 14 and 19, that's 33. 14 plus 19 is 33, divide by 2, and you get 16. Okay, so now your mid is, so if ST is 20, pink is 18, so it's 1. Pretty sure that 1 is at position 16. Okay, so yes, let's double check. 3, 6, 9, 12. Wait a minute. Oh, 16, yeah. So that, yeah. So let me do it again. Yes. So we're looking for 16. E is 3, green is 6, JTA is 9, many is 12. And then, yeah, the one is at, yeah, the one is at position 16. 3, 6, 9, 12, 14. Yeah, that's right. Okay. So one is at position 16. Sorry, students. Okay, so and 1 is greater than the key, right? 1 is greater than, yeah, NO, right? So O is greater than N. Okay, so we're going to look to the left for the next iteration. So low stays 14. We're going to reset high because we're looking to the left. So because 1 is greater than S, so everything to the right of 1 is greater than S. So we're going to look to the left. And really, at this point, there's only 2 left, NZ and ON, right? Because everything else has been eliminated. Your low is 14, and then your high is going to be mid minus 1, which is, so your high is going to be 16. I'm sorry, your high is going to be 15. And your mid 14 plus 15 is 29. And so your mid is going to be 14. Okay, so low is 14, your mid is 15, your low is 14, high is 15. So that means your mid is 14, right? Let me write it so we can actually see it. Okay, so 14 is happens to be, let's see. So I think that, let's double check it. E is 6, green is 6, 9, 12. The NZ is 14. The NZ is greater than NS. Okay. So so we're going to look to the left. So the next time we look to the left, so we're going to reset, right? So the iteration actually resets, right? Okay, so mid of 14 is greater than NS. Okay, so we're going to reset high. So your low is going to stay 14, and your high is going to be 14 minus 1. So your high is going to be 13. So now let's look here, students. So your low is 14. Okay, so in the fourth iteration, low is 14, high is 15, and we calculated mid at 14. okay? And so now so the next iteration, low is 14, high is 13, and now let's go to our loop. And what do we see? Our high is not greater or equal to low, so we stop. Right? So this actually doesn't even count as an iteration. Yeah, so when we go into iteration 4, low is 14, high is 15. And students, let's look. We actually calculate okay. So low is 14, high is 15. The first step is to calculate mid. Mid gets calculated at 14, and we see that numbers of mid is greater than the key, so we reset high to 13. So in the fourth iteration, we set high to 13, the low is 14. So we can't even get into the fifth iteration because that Boolean expression 13 greater or equal to 14 is false. So there's actually 4 calls to binary search. So what happens then? So the while loop is false, right? That Boolean expression high greater or equal to low is false. So we return -1 because we have these 2 return statements. Okay, so that's all. So we've seen 3 examples, 1 with an integer, 1 and 2 with strings, 1 where the string was in the array, 1 where the string was not in the array.